Okay, this video is going to be about your final project and making a physics engine with HTML canvas. If you decide to make the physics engine, you need to go ahead and watch the animation video first. A lot of that stuff copies over. So I'm going to go ahead and take the animation HTML file and start there. I created an engine.html. This is where I'm going to start. So let's back up a little bit. We're going to change start animation to start engine. Okay, we're going to do start engine, and then our background color, we're just going to make it a gray to start with. We're going to get rid of the sky and the grass and all that. We have it's a nice gray color. We'll do 640 by 480. Okay, we're going to draw the background to start with, and then start the engine, starting engine. And the next frame we're going to call start. Okay, we don't have frame numbers. We don't have frames. And our frame delay doesn't exist either. Okay, so the main difference between the engine and an animation, the animation, you have a set amount of time between each frame that's drawn. Okay, with the physics engine, we need to rely on actual time to calculate things. So everything has a speed, has a velocity. You might add acceleration if you wanted, but everything, the movement of all the objects behave in a similar fashion as real objects in the world. So we're going to have something that equates to gravity, so that's like 9.8 meters per second, and everything, we're going to basically just start out making little circles, and we're going to have them move around the screen, and we're going to have it generate multiple circles, and they'll just bounce around the screen. Okay, but it's going to behave in a manner that's similar to physics. Okay, so instead of doing the delay between the frame here, there's no frame delay anymore. Okay, so all this stuff is gone. We are going to draw the background each time, and then we draw our circles. Okay, so we get rid of all this Mr. Block stuff and the frames. Alright, so we got our canvas element. It runs, there's a button underneath that runs start engine when you click it. We draw the background initially, and then when you start the engine, that's when we start things. Okay, so I don't have a frame. Okay, so set timeout. Actually, we will call it frames. Technically, you do have frames, like in a video game. Depending on how complex the physics are that's going on in the game can render so many frames per second. So if there's not a whole lot going on in the game, generally 60 frames per second is really good. And a lot of graphics cards will do way better than that. If it's very complicated, a whole lot of objects interacting and a whole lot of calculations that the computer has to make, it might drop down to like 30 frames per second. Okay, so it's not a set time frame between each frame like in the animation. That's the main point to take away here. Okay, so we're gonna call this next frame. Okay, and then draw circles, draw background, draw circles, and then set timeout. We're gonna do next frame. and we're going to say next frame, we'll just say 10 milliseconds. We'll make it super fast. You could theoretically you'd want to do like 0, or you want a little bit of gap so that way the mouse can move and stuff. If you bog down the system and it's constantly rendering frames, then it won't be able to process other things. So you want a little bit of space between frames, but not much. So we'll just say 5. Okay. So now what we have to do is we have to make a function to create these circles. Okay, our circle object, we're going to make an object it's going to have an X and Y position, and we're going to make that math.random. Math.random returns a random number between 0 and 1. It's a decimal number. What we want is a random X position on the canvas somewhere. Okay, so this is going to be math.random, and it's going to be between 0 and 640. So we multiply by 640. And then the Y position is going to be a math.random. Oh, we also need to take the floor of this to remove the decimal places. You don't have to, but the canvas can render decimal places, so actually, yeah, we'll just leave it. Math.random times 480. Okay, so it's a random number between 0 and 480. Then we're going to have a radius, R, is going to be math.random, and we'll say the radius, we'll make it somewhere between 15 pixels and let's say 50 pixels. So first you multiply it by 60 because it's between 0 and 1. The lower bound is 0, so if you multiply by 50, that's 0. The upper bound is 1, so if you multiply by 50, that's 50. So our number can be between 0 and 50 now, since we multiplied by 50. And then if we want to make it 15, start at 15, then you have to add 15. Okay, but then that makes our maximum 65. Our minimum is 15, and our maximum is 65. If we want our maximum at 50, then we have to subtract 15 from what we multiply by, so that's going to be 35. Okay, so the radius is a random number, we multiply by 35, that'll give you a number between 0 and 35, and then you add 15, and that'll give you a number between 15 and 50. Okay. So that should be all we need, and we return circle. So this creates a random circle. Okay. So we are going to need an array of circles that we're going to keep track of. Now you might use blocks, you might use paddles, there's any number of things you could be drawing here. I'm going to do this as simply as possible and just use circles. We create random circle. When we start the engine, we need to fill up this array with a bunch of circles. So for var I equals 0, while I is less than some number of circles that we want, say it's 100, I plus plus. Okay, semicolons between each expression. That's the initializer, that's the loop check, and that's the incrementer. Alright, So we want circles dot push create random circle. So we're adding to the array a new circle object every time. Okay, and it's going to have new random numbers in here. So this is a physics engine, so besides x and y, we also need velocities. So that's basically the speed. And we need a velocity in the x direction and a velocity in the y direction. And then we'll say acceleration, we're just going to call gravity. And that's going to be the same for all of them. So we're going to leave that off and make that a constant up here. Okay, so we also need to decide on our canvas how many pixels we want to represent like a meter. So if gravity is 9.8 meters per second squared, okay, we need to figure out how many pixels there are per meter. Okay, and we're going to say px underscore m is going to be pixels per meter. Let's say every 10 pixels we're going to call a meter in our world. Or actually let's do 50 pixels. Okay, so on our canvas we're making a scale. 50 pixels is approximately 1 meter. 50 pixels per meter. Okay, so we have an initial velocity of x. So let's say we're moving between, we can go positive or negative in the x direction. Okay, and we want it to go anywhere between 0 and let's say 10 meters per second. That might be kind of fast. We'll see though. We'll see how it works. So we need a random number between negative 10 and 10. Okay, so our range is 20. So math.random, our range is 20, so we multiply by 20. This is going to give us a number between 0 and 20. And then you subtract 10, and that's going to give us a number between negative 10 and positive 10. Get an extra parenthesis there. Yeah, okay. And then for y velocity, we'll do the same thing. So the ball might start up moving up, but the acceleration due to gravity is going to constantly change velocity in the y direction. Okay, so what we're doing is we're mimicking the physics in the real world. Every object has a speed, and all the forces act on that object. Okay. So here, what we also need is a variable for the last time frame. So last time, and to get the time in JavaScript, you do date.now. That returns the number of milliseconds since 1970. Okay. So if I go here, date.now. And if I do it again, see the milliseconds, that was 2 seconds later, or a second later, right? 1 Mississippi. Okay, so this is about, we're at 5 seconds. These are milliseconds, so 1,000 of them is 1 second. So we're at like 5.7, I waited 1 second, and we're at 7, right? So that was 1.3 seconds. Okay, so if you subtract these two numbers, that tells you how much time has passed between each frame. You subtract the current time minus the previous time, the last time, and that's the amount of time that has expired between frames. And that's how you calculate your new x value, your new distance. Okay, that's how you calculate the next position of the object. So last time we start out at date.now, and every time we render, we make a new last time. Okay, so next frame, we're going to say var now equals date.now. And at the end, we're going to say last time equals now. So last time is the time that we use to render the frame. And so next time we render a frame, we need to figure out how much time has passed so we know how far the objects have moved. Okay, so you always have a now, and you render based on the difference between the last time and now, and then you have a last time. Okay, so draw circles is going to need to know the current now. So we pass that in. Okay, so we've created our random circles. We've got an x, y, a radius, a velocity in the x direction and a velocity in the y direction, and a gravity. So draw circles now. Here's our now. So now we need to go through our array of circles up here. And for each one we need to draw it. Okay, so we make a for loop for variable I equals 0 while I is less than circles.length I plus plus and then draw circle and the circle we want to draw is the circle in the array. So variable circle equals our circles array and the item at index I. So this for loop is going from 0 all the way to the end of the length of circles, so it's iterating through each circle in the array. We get the circle and store it in a variable, and we're going to create a function called draw circle, and we pass it in the information from this circle. Each circle is different. Each circle has its own x, its own y, its own radius. Each one of them is different. Okay? So we draw circles, and this just iterates through the loop and draws one of the circles. So now we make a function draw circle, and we get an argument. It was passed in here. Here we're calling the function. This is the function definition. Okay, so we have draw circle, and now we get into our canvas stuff. Okay, so before we draw each circle, we need to calculate its new position. Okay, so we do, it also needs to know now. Okay, so to get the difference in time between the last moment we drew something and now, we take now, so this is called the time delta. The delta just means difference between two things. So the delta here, or we'll just call it t, is going to be the difference between now, which is the number of milliseconds from 1970, to now minus last time. And last time was the number of seconds from 1970 to when we did date.now. So there should be a slight difference in time here. It should only be like 5 to 10 milliseconds, but it's going to change every time depending on how much we're rendering on the screen. So depending on how fast the computer can go. If we're running other things in the background on the computer, it might go slower. So that's why we need to calculate the time. Alright, so t equals last time. So now we need to get the new x and y. New x is going to equal the original x, circle.x, and then we're going to add to it, and the velocity could be positive or negative. So we're going to add to circle.vx times this time. Okay, now this Vx is in, yeah, let's ignore the pixels per meter to start with. So right now the x and y are in terms of pixels, not meters. Okay, so this is going to give us the velocity of x, and then we multiply that times time, and that's going to give us a distance. So we take the old x and add the amount that it traveled, and that's going to give us the new x. So circle dot x is going to equal new x. Then we're going to do the same thing for y. And really we don't need this variable since it's just basically one line of code. We can do circle.x equals what it equaled before plus the velocity of x times t. Okay, we're not going to do gravity right away. First we're going to just get everything working. Okay, so now we need the y value. So the new y value is circle dot velocity in the y direction times our time. Okay, so we got a new x and y, and now we do the canvas stuff. So context dot save, context dot restore. Now we're going to draw a circle, so context dot begin path, context dot close path, and in between we do the arc, context dot arc. And this is going to be circle dot x, circle dot y, then the radius is circle dot r, and then the starting position is 0, and we go to 2 times math dot pi. Oops. Okay, and then we do we'll make these all red to start with, but you could also do a random color. Okay, so that's something you can do on your own if you want. So context dot fill style equals red, and stroke style is black. Context dot fill, context dot stroke. Okay, so this should draw one of the circles. We pass in the circle and then the now. And we get the time delta. That's how much time has passed since the last frame. We calculate the new x and y positions. And if we're doing gravity, we would calculate the new y velocity by multiplying the acceleration by t. That will give us an increase or decrease in the y velocity for the next frame. Okay, so let's see what we have. Oh, not there. Engine. Okay, I need to change the name up here from animation to engine. Okay, at engine.html 47 I have a bad token. Okay, I accidentally added a slash there. See, I just clicked on that in the console. If you click on it, it shows you the code and shows you the line. Alright, so in my for loop I accidentally added an extra character. Line 47, right here. Okay, so we got our gray background. That's working. Title is engine. Click start. We got another error. Next frame is not defined. Engine 66. Next frame. If it started. Set timeout, next frame. Oh, there it is. Next frame. Alright, start. Okay, so it's doing something. We've messed something up here. We've got a bunch of balls moving around. So we're sort of on the right track, but we need to figure out what we've done wrong. Now notice it's drawing the background. It tells us each time. So each time it's drawing one of these frames. Okay, so let's take a look at what we did and see what's wrong here. So it's drawing them all in a cluster up here. Okay, so the x and y position is a math.random times 640. So let's look at that in the console. Okay, that seems to be right. It's picking an x number between 0 and 640. This should be right. Let's see what this radius gives us. Okay, this should be between 15 and 50 every time. That looks right to me. Okay, our velocity in the x direction should be between -10 and 10. Okay, that looks right. Okay, so we're creating the circles right, it looks like. So let's look at let's move the the calculate new positions up here in the for loop. So draw circle is only drawing. That's console.log t. Let's see what t is each time. Okay, so this is kind of right. It's about 50 milliseconds between each frame. Okay, we got to figure out why it's bouncing around like that, though. Alright, oh. So here's the problem. This needs to be plus equals. You want to start with circle X and start with whatever position X is, and then add to it the velocity times the time. I was just changing it to velocity times the time. Alright, so both of these need to be plus equals. Okay, so that's sort of working. Looked like there was only one ball though. Circle.r. Okay, this is circle y plus equals. Okay, let's start debugging this by making it one circle instead of 100. Okay, so we make a variable up here, var num circles, and then we can set that at 1, and then later we can just set it to 100 and it'll do 100. Okay, so start. So now notice it's drawing way fewer of them, and so there's like 5 or 6 milliseconds between each frame. Okay, but something's not right because it doesn't seem to be drawing it. So next frame we draw the background. So it's drawing the background, and next frame draw circles. So draw circles goes in here, logging the t, and we need a console.log circle, and we'll see what data we have in circle. Okay, so now we need to make it so we can press start and it'll stop. Okay, so start engine. If it has started, we do this. Or if it has not started, return. And then otherwise we say has started equals false. And so in next frame we check to see if has started we do that, and otherwise it just returns, it stops. Okay, so start and then we stop. Now we can look at this. We have, okay, so the X is getting really, really, really big, really quickly. And so is the Y. So our velocity is way too high. That's what's happening. So we don't even see the ball being drawn because the velocity is so high. Alright, so our velocity needs to come way, way down. So let's make it between 0.5, negative 0.5, and positive 0.5. Alright, so now let's try that. Still getting really big. So this is between, oh whoops, that needs to be the 0.5. And then we'll subtract 0.5. So this just needs to be 1. Between 0 and 1, our range will be between 0 and 1. And if you subtract 0.5, the velocity in the x direction could be between negative 0.5 and positive 0.5. So let's see what this looks like. Okay, that's still getting big really fast. Let's do 0.1 times 0.2. Now this is where your scaling comes in. So if I had used my scaling pixels per meter, I would know more about the size and how to set the velocity, know what a reasonable velocity is. Right now I'm doing pixels per second, which it's not rooted in actual physics, so sometimes it's hard to figure out exactly what speeds you want so you can see it. Okay, the y value. So the radius, we should be able to see some of these now. X and Y. Oh, I commented out draw circle so I could console log it. That was the mistake. Okay, so we got a ball in there. Okay, so let's make it every time you click start it resets. So we have to reset all the circles. And so we make circles equal an empty array, and then we repopulate it every time we hit start. Okay, right now it's just one ball. Okay, and we can go up here and we can say instead of one circle we want 100. Okay, so that's basically the physics engine, and you could put boundaries on your calculation of their position. Okay, so right now we draw the circle. All this is doing, this is calculating and drawing. Okay, what we probably want to do is calculate positions of circles separately. So next frame, before we draw circles, we want to new positions. Calculate new positions. Alright. So we make a function to calculate new positions. Okay, we need to pass in, in fact we can make t up here, or t equals now minus last time And so we'll just pass in the delta t. And to calculate positions, so that's a new time value. Draw circles doesn't need time anymore because it's just drawing the circles, so it doesn't need that variable anymore. And neither does draw circle. So all of this is doing is checking the circle object, where is the thing, and draw it. So the calculate new position is where we can do the interesting things. We can do the physics here. So you can make these objects collide with each other, and if they collide, you can change the x and y direction if it collides with the wall. So if the x position is less than, if it's a negative value, you basically have to make that a positive value so it bounces off this wall. Okay, so if the x position is greater than 640, then you have to change its x velocity to negative, and then also whatever distance past this boundary it is, you would render it over here. Okay, so as an example, we can say we'll have to do new x equals circle dot x plus that. Okay, new y, circle dot y. Okay, so if new x is less than 0, we need to make new x the absolute value of itself. So we need to basically multiply it by -1 to flip its distance. If you multiply by -1, it'll flip it over here. So new x equals new x times -1. And then we also need to flip the y or the x velocity to negative. Circle dot x equals circle dot x times -1. I guess this can still be circle x. Okay, so now anything that contacts this border, the center of the circle, as soon as it gets here, it should bounce the other direction. Calculate new positions. Calc. Now is not defined. .94 T. Oh, that's right. Positions. Yeah. We need to, we're passing in T now, we're not calculating it ourselves. Okay. So, do that. Console circle is not defined. Okay, so we need to make our for loop for each circle. We do this. Okay, so for variable 0, while I is less than circles.length, I plus plus, and we need var circle equals circles I. So now we have a circle variable. Now we are still going into the next, the negative x area. So if circle.x is less than 0, circle.x should equal circle.x times negative 1, which should make it positive. And then, oh, here we go. I'm just doing circle.x times negative 1 times negative 1. So we have the velocity of x has to invert as well. So we're inverting the position of x because it's crossed over here into the negative, and we put it back into the positive, but we also have to change the velocity to be going this way instead of this way. So we have to do it to both the x position and velocity in the x direction. Okay, now see, this is going to bounce. You see it bounce? Anything on this edge now bounces. And you can do that with all 4 edges. And you can add gravity. And so if you have it with the bottom edge, you can have balls bouncing off the ground and just bouncing all around. Okay, so this is the basics to get started with your physics engine. You don't have to use balls. You can use squares. You can do whatever you want. But you need some sort of physics engine. It doesn't have to be a game, but something where all the pieces move based on time and have a speed and in some way behave like natural physics. Okay, so that should be enough to get you started. And if you have any other questions, you can hit me up on Slack or send me an email. Good luck.